afternoon, everyone. I hope you're having a great day so far. I'm Shweta Shri from third year CSC, studying at KCG College of Technology, and I would like to welcome you all to the Industry Speaks core session conducted by PALS and hosted by KCG College of Technology, Chennai. Today we have Mr. Krishna Kumar, our distinguished visiting professor, AICTE INAE, and former Senior Vice President, Lucas TVS, who will be speaking on the topic Product Reliability Engineering. We will then be having an interesting quiz for you as part of the event. Also, after the speaker session, we will have 3 student teams, each from KCG College of Technology, MAM College of Engineering and Technology, Tyagarajar College of Engineering, who will be presenting a few intriguing topics. We will conclude this event with a quick Q&A to keep you all engaged. I kindly request everyone to follow the Zoom code of conduct, which is kindly stay muted if you're not the speaker. Please record your attendance in the attendance form, which has been posted in the chat. If you've not already registered, please register with the registration and attendance forms. You can ask your questions during the question and answer session, and the feedback will be posted at the end of this session where you can submit it. Now over to Mr. Arun Dev, who will be giving an introduction to PALS.
Hello. Robin?
Yes, sir. I request Ram to give intro.
I'll be starting the session. So very warm good afternoon to all the speaker of the day, Mr. Krishna Kumar, Dr. Annie Jacob from KCG, who's the host college, faculty members, and all our young friends. Now, it's my duty to introduce PALS, but since the offerings are so much, I'll stick to this offering of today. Over the years, PALS has added to its array of offerings in terms of number of events and enhancement of content and engagement of the audience. Particular, the events Acquire and Aspire are now called Industry Speak this year, in line with the fact that PALS has increased the engagement of the industry across core and digital sectors with dedicated supporters, and then with support from experts in industry, not only for speaking to the students, but engaging them in interactive ways to enhance the learning experience that will make students industry ready. It will be the privilege of the host to introduce today's speaker, but I will just say that today's speaker, Mr. Krishna Kumar, has 4 decades of rich experience in companies known by customers for their reliability, namely L&T and TVS Lucas. He has been driving the reliability of products in these companies, and today's topic is relevant for all disciplines, for students and for life itself. I would like to say a few words about reliability from my viewpoint, because I have been in the foundry industry for 4 decades, and having been a supplier of castings to the textile machinery, pump and automotive industries, I have faced a lot of challenges. As a supplier, I have learned that the castings must not only serve its intended function, but it must have aesthetic appeal, be able to withstand the rigors during the process of transportation, assembly, etc. Even at that stage, things can fail even before they go into the product. Today, there is a lot of debate on the reliability of the upgraded Boeing aircraft 737 MAX, and the story will serve to teach a lesson to engineers to be careful about doing anything for profit that is not desirable for the customer. So on that note, I would welcome all of you to make the best use of this session and to be engaged. And then it is as difficult to, not only to please speak like today's speaker as a customer on the other hand. And in life also, it is very tough to be a good spouse. So with these words, I will leave it to the speaker to speak about you and about reliability. Thank you.
Thank you, sir, for the fine introduction. It was quite insightful. Before we start with the speaker session, I now request Dr. Annie Jacob, Director of KCG College of Technology, Chennai, who is an alumna of IIT Madras, to deliver the inaugural address.
Good afternoon to all. It's my pleasure today to deliver this afternoon the inaugural address for the session on Industry Speaks Core, and a warm welcome to Mr. S. Krishnakumar, Distinguished Visiting Professor, AICTE INAE, and former Senior Vice President Lucas TVS, and to all our viewers who are attending this session today. In the present competitive world, the competitiveness between organizations has increased the demand on the production systems. The customer satisfaction actually depends upon the production systems' capability to deliver the quality goods and services on time. To do so, the systems must be reliable. The advanced technology is in fact very complex, and it includes different types of components such as software, hardware, and not to forget the human factor. Reliability is the principal property of the system, which is an important parameter to decide the life of any biological and human-made system. The reliability does not just apply to machines and equipments. It is something that also takes a company further trusted, keeps the customers satisfied, and the future of the company going with the products and services they deliver. Now, bringing it to a scenario like educational institution. How could a higher education institution claim that the education that they give is reliable or credible? Being so intangible, it's unlike products where there is more touch and feel. Now, this all depends upon the development of students on any engineering campus and making them ready to meet the expectations of the industry. The way to take forward engineering education for the future need is definitely with holistic growth. And this can be with mainly 2 pointers. I would put it across them, and that is what we believe in. Developing professional skills for sure, like effective communication, teamwork, critical thinking, design thinking, problem solving, leadership skills, and not to forget also project management skills. Secondly, and even more, this is also very important, develop them both technically with fundamentals and technical skills that are required for the 21st century, and also the high demand skills of the future, be it artificial intelligence, be it Internet of Things, cybersecurity, data science, machine learning. And there are many of them that have come forth, and these are all possible through effective industry-institute collaboration. Now, this is exactly where PALS has helped all their partner institutes immensely. And our experience with PALS has been very overwhelming, being associated with PALS for over 5+ years. PALS, a bridge for an industry-centric experience, offers such core expert sessions in addition to various other activities. In fact, Mr. Ram was mentioning about it. There's been a lot of activities, be it Innova, be it hackathon, be it internships. There are many activities of PALS which has been highly beneficial for the students. In fact, during this pandemic situation, I think virtual labs and some of those virtual industrial visits have been very beneficial to the students as well as the faculty. Especially to say about today's session on Industry Speaks Core, Mr. S. Krishnakumar will be speaking on the topic Product Reliability Engineering, as mentioned before. This main session will be a lecture by the industry expert, again, which will help the students understand the importance that is associated with the future and demand skills, which will definitely act as a differentiator. How do they differentiate themselves in a student community? The next interesting part, which even I'm looking forward to, is the students' presentation, where they learn about team research, and the presentation has the topic that has been given by the speaker. They interact with and this will develop, which will help them, apart from developing the self-learning ability and technical knowledge, this is also going to help them the research skills, how to develop their research skills. We would like to actually appreciate PALS for giving us all these immense opportunities to the academic institutions and our students and faculty in a very unique and reliable way. Looking forward to the session, and thank you very much.
Thank you, ma'am, for the lovely inaugural address. Now let me introduce our respected speaker, Mr. Krishnakumar, to the audience. Mr. S. Krishnakumar is presently the Distinguished Visiting Professor, AICTE INAE, Adjunct Professor in VIT University, Vellore, Consultant to the engineering industry on new product development, R&D, lean manufacturing, quality, and reliability. He retired from Lucas TVS as a senior vice president in engineering, R&D, and quality after serving in the company for 20 long years. With a meritorious performance in his PG from IIT and MBA from University of Madras, Mr. Krishna Kumar has also been awarded the Vijayashri Award by the Government of India for innovation in naval equipments. Over to you, sir. The floor is yours. Thank you.
Yeah. Thanks for a very good introduction. I hope I'm audible. If you have any problem, please let me know.
Yes, sir.
Yeah, okay. I'm also visible, am I right?
Yes, sir.
Right. Before I really start talking about reliability engineering, I thought I would talk a little more about general things. For example, I am very happy to be associated with KCG College today because of the sponsorship that they have offered. Way back from 1963 onwards, Dr. KCG Varghese, the founder of KCG College and the KCG, the whole group, Hindustan Institute of Engineering Technology, all that, has been my close friend. We have been playing tennis together in Gandhinagar Club for maybe 3-4 decades. And unfortunately, he passed away, I think maybe about 10 or 15 years back. And after that, his sons also I know very well. That is apart from the story that I'm going to talk about. See, the reliability engineering, I was very happy that Ms. Annie Jacob had realized that reliability is very important in educational institution as well. Many people don't think that education institutions are selling education. They are really giving away education to students, and it's a business. At the same time, you know, the days of Gurukulam and all that is continuing in some of the places through this kind of interactions. It is not an impersonal teaching that is taking place in most of the institutions. This is what I understand because I also visit several colleges. I am attached closely to RMK, VIT, Anna University, College of Engineering, Guindy, so many other places, IIT Madras. So I noticed this. Now, before I talk about reliability engineering, you must all know that reliability had started with the institution of insurance, life insurance. Way back, maybe about 3-4 centuries back, Lloyd's started the insurance business in UK for the ships. You know, like that, the life insurance had become very common. Today, life insurance is a great business in India and abroad. Life insurance policy and the premiums that they talk about, they are all based on reliability engineering only. Please understand that. And they go on revising the premium over the years based on the longevity of persons and also the kind of diseases that people get. So this is the background of reliability engineering, which had been borrowed from insurance into the industry. I belong to a core engineering industry in which I have been using IT to a large extent, maybe from 1968 as a CAD user, then EDP and so many other things. You know, I am also very conversant with CAD, computer-aided engineering, innovation, so many things that I can talk about. I am not conversant with business part of IT, okay? So please understand that. And most of my examples will be from automotive industry in the last 20 years. Whatever I have done in automotive industry in Lucas TVS, I have learned from Japanese and Koreans. I had consultants way back in 1997 onwards, based on which the Deming Prize for Lucas TVS was obtained. Deming gave a grand prize. Then the reliability engineering, I was trained by Professor Suzuki from Tokyo Electrotechnical University. I've been to Japan several, maybe 20, 30 times to see what people are doing in terms of reliability. So that is the background of this. So I thought with this thing, I would like to share my screen and start my talk. If you have any question at any point of time, please note down. And then at the end of it, end of the lecture, there is a quality question and answer session in which you can ask questions and I can answer to the time, within the time available. I think PALS PMO will help in that regard.
Yes.
Now, my talk will be more on product reliability engineering, and the product can be extended to services as well. When I say product, it can be any product of any discipline: chemical, electrical, electronics, mechanical, anything that you can talk about. I have not done much work in IT reliability engineering, but I have done all other things. But that's why I said that I belong to the core engineering industry. So I would like to talk about the relevance to the industry, why we are talking about, and how we
Mr.
are.
Krishna Kumar, sorry to intervene.
Yeah.
That your voice is little bit low. Can you increase your?
I think it is at the maximum. I'm not very sure of that.
Yeah.
I will try to talk a little. I have a.
Okay.
Okay, let me try.
Okay.
Okay, so I would
Thank
like to talk about the relevance to the industry with certain case studies at the end of the presentation, wherein how we are using reliability engineering is also explained in that. Presently we are talking about Make in India. I would like to give a background of why we are talking about reliability engineering in the industry. Please understand, reliability engineering is in the very nascent stage in India. Most of the industries don't do any reliability engineering work. Only few companies are doing today. There are two reasons. One, MNCs, if you look at, they take care of reliability themselves. They don't allow our engineering or quality or reliability department to work. Whereas the companies like Lucas TVS, almost all TVS group companies, we depend purely on in-house R&D. So look at TVS Group, maybe Rane Group, Tata Motors, Mahindra and Mahindra. So these are all the companies which are depending mostly on reliability engineering to pick up in India. And we are working on reliability engineering in a great way today. Lucas TVS, my presentation will be more based on what we have done in Lucas TVS, basically because we are the pioneers in reliability engineering. Please understand that. So I thought I would give a background of this. Make in India program of the Government of India is driving reliability engineering. How it is doing, I would like to talk. If you look at this, India has got an advantage. Are you able to hear now?
Yes, sir.
Right. India has got an advantage. The largest two-wheeler manufacturer in the world is Hero Motocorp. Many of you might be knowing earlier as Hero Honda. So they hold 46% in the two-wheeler category in India. Number one global manufacturer of motorcycles is in India, Royal Enfield. If you look at the total output of Harley Davidson, KTM, BMW, Triumph, Ducati, all these people together, that has not exceeded Royal Enfield's 1 year sales before pandemic. I don't have the data during the pandemic in 2020. I think that may not be relevant today because that is only a disastrous year. The largest farm tractor manufacturer in the world is Mahindra and Mahindra in the world. Please understand that. Largest commercial vehicle manufacturer in Asia is Tata Motors. Second largest small segment car manufacturer in the world is Maruti Suzuki. If you look at all these companies, I consider all of them as Indian, including Maruti Suzuki, because Maruti is almost 99% in Indian in working and in concept, even though they may be having Japanese joint venture and all that. If you look at why I'm talking about Maruti like that is, in 1985, when Maruti came into India, they showed us the way of improving quality by a breakthrough. And they showed us how to do lean manufacturing. They showed us how to do inventory management. They showed us how to do the complete reliability engineering in India. Today, many companies are doing. So I consider all these are Indian companies who are having this advantage. No MNCs having any advantage in India today, in automotive industry. Present scenario in the Indian industry, increase internal competition, MNCs compete with Indian companies, fluctuating market demands. You know, the market demand for various products, they go on fluctuating every day to the extent that Maruti is presenting in their website portal every day at 3 o'clock what delivery of components are required for tomorrow. There are about 600 suppliers for whom they publish this every day, and Lucas TVS is one of them. For the last 8 or 10 years, we have been doing this. 50% of tomorrow's production, we are going to supply at 8 o'clock, the balance 50% at 12 o'clock. They go straight into the assembly line without any quality check, and the reliability is assured. So that is the kind of thing that is happening. And why I'm talking about it is, in Maruti, they make somewhere around 170 varieties of products. When you look at Alto XS, VXI, LXI, 8, AMT, so many varieties are being made in every model, and they go on fluctuating every day. How we do this, our forecasting is a different story, which I don't want to talk here. It's a customer-centric market today, wide choice available to customers. If you want to buy a TV, you go to a TV shop, you find Sony, LG, Samsung, Videocon, all the Indian companies and the foreign companies, and the prices are almost the same. They may be made in India, but the point is it's an MNC. So price is almost the same for the same features. So no import restrictions. Secure B2C online transactions. If you look at fast deliveries, especially during pandemic, I think most of us have been buying our daily requirements and also our capital goods, our vehicles online, and trying to do B2C online transactions. They are all quite secure. Common tax structure across the country, that is a GST. So this has produced a challenge to the Indian market. Faster response to change. Deliver the product before the customer changes his mind. We have got to deliver the product before the customer changes his mind. In Maruti, as I told you, next day, they will give me a list of 70 different products. WagonR LXI, WagonR VXI, 20 numbers, 30 numbers, 40 numbers, like that. So they have a multi-model line, a lean manufacturing line, in which they go on getting varieties of vehicles on the same line. The same line, you will find XL6, you will find Swift, you will find Swift Desire, you will find WagonR, all these cars coming in the same assembly line, and the workers know what to fit where, because everything is computerized and automated. Multicultural environment. Now, return and warranty policy without questions asked. When you order certain things on Amazon or even Big Basket, if you want to return certain things, whatever, where there is a policy, straight away you can return it without any question to be answered. So that happens everywhere in every business today. Multicultural environment, Japanese, Korean, American, Indian, I've already talked about it. Adherence to globally accepted standards of quality, cost, delivery, and service. Quality is taken for granted. When you want to buy a two-wheeler, for example, you can ask TVS or Hero or Honda motorcycle, or any of these things, people to come and show you a test drive. You can select your product based on what you want, and you tell them that you need this product. The next day it is delivered to you, but what is delivered is not the same as what you did test drive. Please understand that. but the product has got the same quality, same features, everything same. And delivery, if there is a delivery delay, nobody wants it. People want to cancel the order. Higher value addition is expected by the customers. So this has made people work against Kano model. I don't know how many of you know this Kano model. I don't want to spend much time on this because we have got to talk more on reliability engineering. I thought I would highlight this because customer satisfaction is not what is required today. Customer delight is required. When you get into a Ola car, Ola taxi, you want to play games on the screen, whereas in Uber, it may not happen. So like that, there are varieties of things which gives delight to the customer. When you take a mobile, you know how it has transformed over the years and what features that you have today for delighting a customer becomes obsolete tomorrow, and you've got to find out something new next day. Now, I am going to talk about new products. Why companies are coming out with new products? If you look at Maruti or any automotive industry or even mobile or TV industry or any of these electronics, they go on producing new products, NP1, NP2, NP3, what I've shown here. So the project starts much earlier and it goes on, and the expenses are made initially and the sales take place. So you do the NP1, you can follow my cursor. NP1 is a new product which produces the revenue over a period of time. The return on investment is shown in dotted line. Now, unless you produce another new product, NP2, within a short period of time, you are going to have a fall in your revenue. When you make a product which is having a breakthrough in business, this blue curve will go up further, and then you get a breakthrough in business and you really succeed. Or in other words, if you want to sustain the business and grow, you have got to do new products. Now, I am coming to reliability. How is it relevant to the new products? What is reliability? Is reliability mathematics or statistics? I find in Anna University syllabus, I have gone through the syllabus of Anna University because I am also attached to some of all the colleges of Anna University through AACTE, INAE. So I find quality and reliability is an elective. And if you go into the details of that, most of it is statistics. So people don't look at reliability. The students don't select quality and reliability. Even though quality is very important, reliability is not important. That's what people think. But it's the other way about. Is it reliability, mathematics, or statistics? What is the definition of quality? Quality is customer satisfaction. If the product satisfies the customer, the quality is satisfied. Reliability is customer satisfaction from the viewpoint of time function. When you look at customer satisfaction over a period of time, a specified time, specified environmental conditions, then it becomes reliability. Now, why is quality important? To ensure that the product meets the performance specifications. Generally, at the end of the line, we put a test rig to test the product. In most of the automotive companies and also in electronics, or where large volumes are produced, we do the testing. I'm not talking about some of the products like PSLV and all that, where you can't do the testing of the product at the end of the line unless you really launch it. There are a lot of testing done for in-between components, sub-assemblies and other things, wherein the quality is ensured. So, if the product meets the performance specification, what the customer has told as a performance requirement, it means quality is achieved. Now, reliability is measured as parameters like MTBF, mean time between failure, mean time to failure, beaten life. We will see all this in very brief manner in the next few slides. And ultimately, by repeated purchase of the product by the users, people go on buying LG TV, for example, LG Smart TV. I got a 42-inch LG Smart TV. I would like to replace it with a 55-inch LG Smart TV. Or Samsung or any other thing. When you go in for a Maruti Suzuki, you buy a Swift car, you run it. After some time, I would like to go for Swift Desire or Brezza or any of these things. If there's a repeated purchase, that means the product is reliable. That's a proof of the pudding is in the eating. Now, these are all measured by MTBF, MTTF, beaten life. What is meant by warranty? Many people don't really realize what is warranty, what is guarantee. In contract law, warranty has various meanings, but generally means a guarantee or a promise which provides assurance by the manufacturer to the user that specific product, facts, or conditions of performance are true or will happen definitely during the warranty period. That doesn't mean your reliability should be restricted to warranty period. If the reliability is restricted to warranty period, Ambassador car wouldn't have been driven for 20, 30 years, even though it is not a very highly reliable car. Maruti 800 will not see a life of 25 years, a product life cycle of 25 years. So automotive manufacturers, they give warranty in different types, bumper to bumper, powertrain, drivetrain, and all that. What is the difference between warranty and guarantee? A warranty is usually a written guarantee for a product. Is warranty dependent on the strength of the product design or process design? Many people think that if you design the product to take care of the stresses by doing finite element analysis, many of you in the design stream, in mechanical, will know finite element analysis. Many people in the electronics or electrical industry where you have a motor design, they do the FEM. If the product is able to meet the stress level with a factor of safety, then is the product having reliability? No. Warranty doesn't depend upon strength of the product, but strength of the product is taken for granted. As I told you, quality is taken for granted by the customer. Customer never asks nowadays, how is the quality of this product? They don't ask. Sir, I would like to give you a small episode or whatever happened when I wanted to buy a new Premier Padmini car way back in 1975. At that time, Sundaram Motors was the dealer and I was in L&T. I went to Sundaram Motors and told them I want to buy a Premier Padmini. They said, you have to wait for 3 months. Same way, Bajaj scooter was available after 20 years. That's a different issue today. So when I said I would like to buy a Premier Padmini car, they said after 3 months, the car arrived because I had paid in advance. And they said, we have got 4 cars in the yard. You can go and select which one you want. So I took a mechanic to the shed, to the warehouse at Punamali and selected one car which was good. So that doesn't happen today. What I'm trying to say is you can select the product as it comes. Quality is taken for granted and you are assured of the product quality. Now, new product development is generally done by successful companies in different stage gate processes. Design reviews 0, 1, 2, 3, 4, 5. These have been practiced by me and by Lucas TVS and also Mahindra and Mahindra, and of course to a large extent by Tata Motors, by Sundaram Clayton and so many other companies. We have been very successful. Lucas TVS, I want to give you a picture. When I came out in 2016 or 17, the 85 to 90% of the product invoicing was from in-house R&D. And balance was due to some customers asking for a specific, technical license like Denso, my own competitor, like that. So what I'm trying to say is, this has been practiced. I can talk about this for even a whole day, but I don't want to do that now. In this, validation reliability testing is part of the successful development of the new product. So prototypes are made. If you look at the product proposal is made, then a concept is prepared, detailed design is done, and then prototype testing is done. then initial production, regular production. This is the way a new product is implemented. If you look at Tata Motors or Mahindra, they generally follow this. But if you look at Maruti or Nissan or Renault Nissan or any of these people, these companies, Japanese-based companies and Korean-based companies, they follow this very strictly. They start this maybe about 2-3 years earlier. Now, in this, I would like to talk about factor of 10 rule. When there is a reliability issue, as I have told you already, reliability is maintaining the quality over a period of time. If the product is able to perform the same way over years, let's say 3 years or 5 years, that means the reliability is very good or whatever it is. Now, when you are having a problem after launch, if there is a product launch and then there is a problem, I can cite several examples. One of them may be Nano car. Nano car, I was involved totally in the development of starter and alternator and wiper, and also the headlamps and all that. So we had initially a lot of fire issues, So we had to do a lot of changes in the design. Based on which, here it is shown 10,000x. Whatever is the cost involved, 10,000 times is the expense for the company. If the change is done in manufacturing phase, it is 1,000 times, development phase 100 times. During design phase, if you are addressing reliability issue, 10x. Whereas if you address the reliability issue in concept phase itself, then it is only 1x. Or in other words, there is no real expense. Best practice philosophy, reliability must be designed into the product or process using the best available science-based methods. Now, I don't want to read this. You can read it later. What is reliability engineering? Reliability engineering is a combination of physics, statistics, and engineering. Or in other words, when I said physics here, it is engineering knowledge. Statistics is a small portion. Engineering is engineering knowledge of the design of the product. If you look at the reliability engineering, after the human insurance business, next thing that came into was in electronic industry, not in mechanical industry. Electronic components will fail sometimes at the initial stage itself, or it will remain for long or die at the end of it. So they had to do a lot of reliability engineering studies. So electronics engineering, they took over the reliability engineering very seriously and started doing it. Purpose of reliability engineering, highest level, the information is used. If you look at purpose of reliability engineering is to quantify, test, and report on the reliability of an organization's products. When you say 92% of the product reliability, something great, because it also affects the financial strength of the company. If you look at Tata Motors, when Nano had a lot of failures and they had to stop production after 3 years of production, they lost all the market, they lost the face, they lost the image. I'm sorry to say about Tata Motors here because it's a classic example referred in many forums. So when you have financial strength, the strength will be eroded. So there are different views of reliability. If you want to increase the customer satisfaction, reliability is important. If you want to reduce warranty costs, reliability is important. To increase market share, reliability is important. To decrease the downtime, optimize maintenance actions, increase efficiency, optimize design, reduce cost. All these are very important from the viewpoint of reliability. How do you do this? What affects reliability? Design, first of all. The design affects the reliability. Testing of the product is very, very important at the initial stages of development and also during the production stage and also after launch. If you look at, I gave 3 topics for presentation by colleges. Basically, one of them is on how products are being tested by automotive industry, what you see on the road. You see many times when you travel from Chennai to Bangalore or Chennai to Trichy by car, on the road, number of cars are going with black and white painted or cover covered cars, they are all under testing. They want to test reliability. I will show you some videos of this as we proceed. Maintenance, operation, and all these affects reliability. Now, how do we do this? Quality. Correct understanding of customer needs is very important. So if you don't understand the customer need and produce a product, the reliability will get affected. Quality may be great, but reliability will get affected and it will fail. Now, I can cite several examples of this, but I don't want to go on giving examples from automotive industry. I think in the electronic industry, I'm not very sure of some of the examples. Then planning, the pickup failure modes, early detection of problems, then R&D and design. These people make a dent in terms of reliability engineering in the product. Okay, so steps and reliability methods of quality assurance. These are all steps of quality assurance. This is a reliability method. For example, market information, planning, R&D and design, prototype testing, production preparation, production usage and discard. Now, quality function deployment, redundant design, FMEA, FTA design review. I can talk about each one of them for different timings, but I don't want to do that. I can cite few examples of that. So if you look at this, the structure of reliability. Now, structure of reliability is durability, maintainability, and design reliability. These things contribute to the reliability of the product. Now, MTBF, I talked about MTBF, MTTF, and MTTR, I think few slides back. MTTF, you are installing the asset. When I say asset, or you are taking a car, you are buying an Alto car, and it starts running on the road. First failure occurs. When the first failure occurs, that is the lifespan of a non-repairable asset, MTTF, mean time to failure. So you take different times to failure of different vehicles and take the mean of that, statistical mean. Now then you do the repair. How long it takes for doing the repair is MTTR. Then again it starts. There is one more failure occurs. So that is the mean time between failures. One failure has happened here, second failure has happened here. Lifespan of repairable assets. This is like automotive car. A typical problem for a reliability engineer, for example, we buy bulbs in the market, we fit it in our home, on the, in our lamps, 9 random light bulbs run to failure. So if you put 9 bulbs, we do this testing in the lamp testing in our factory, in our lamp manufacturing. So one lamp fails here. This is a time scale. Second one, third one, fourth one. But there is a cluster of lamps which fail at this stage. So it follows a skewed distribution. Pardon me for using statistical word, but this is a very simple word. Now, typical problem for a reliability engineer, what is the expected life of the product? If you know what is the expected life of the product, you can decide what is the warranty you can offer. Many people offer that, 2 years warranty, 3 years warranty. Now today, Maruti is offering 5-year warranty. Hyundai is offering 5-year. In US, Hyundai is offering 10-year warranty for many of their cars. How many returns or failures are we expecting in the next period of time? Next 1 year, how many failures are expected? You should be able to predict. That is reliability engineering. If you can't predict, there is no reliability engineering. So if you predict, then you can provide for it in your cost or take action to avoid such failures. How much is it going to cost us to develop and support this product, maintain the product and all that? Can we make it more cost effective? MTTF of 30K service hours, 30,000 hours of an LED bulb. This is an example here. Where is the data for design for reliability? First of all, reliability is done through design for calculations, finite element analysis. CFD is computerized fluid dynamics. This is done in many air involved systems like HVAC units, alternators, wipers, all that. Similar products, take similar electronic products, find out what is the failure of that. Field reports from the field collect data on existing failures and do the study. Testing, you do the testing properly, then you will know what it is. Then the warranty claims, what is the kind of warranty claim that we have? Supplier data. So the supplier also contributes to the failure of products. So very important to study what is the reliability of supplier components. Many times, many of the equipment manufacturers, like electrical equipment, like toaster or fridge or AC or washing machine, they say this is an electrical item, I am not responsible, but that is not acceptable in the market. So we say we want comprehensive warranty, like what we do in bumper to bumper warranty in cars. I saw today in newspaper, the court is asking for bumper to bumper warranty for cars to be standardized. When you say bumper to bumper, it includes all electrical items as well, including lamps. That means reliability of this, even the lamps, is very important. Headlamps, rear combination lamps, all that. You can't say this is an electrical item, I am not responsible. Same way, FRACOS. FRACOS is we study the failure and take corrective action. In IT software industry, it is called CAPA, corrective action, permanent corrective action. So it is like that. Data sources in-house, testing during design, qualification testing, life test, quantitative accelerated life test, field data can be badly biased. So these are all some of the problems. So we do the testing in-house and also in the field. Now, I would like to show a few examples of reliability testing. Car crash test. This is a video. I don't know whether the sound will be sufficient, but you can just see that how they do the testing. This is an open YouTube this thing available. You can also see later, but I would like to show here because this is relevant here. This is a car crash testing. Why do they do the car crash testing? Because they want to make sure reliability is there. I think
They are not able
it's not audible. I will give the commentary.
No.
Audible to hear now?
The video itself
we
is
are
not
not
shown, sir. Video is not shown.
Video is not showing.
No.
Yes.
You'll have to, I mean, I
Once
don't think you
again,
have shared
once-
your
Okay,
desktop.
right. Once again. One second. Just give me a minute. Give me a second. Are you able to see now?
No,
No,
sir.
sir.
Now it is coming.
No, it is not. You stop sharing this and share the video, or stop sharing and share your desktop.
Okay, right. Once again. Once again. Are you able to see now?
Yes, sir.
Yeah.
Okay.
This is actually a car crash test that he's showing. I don't know how many of you had chance to see any car crash test. I've seen many of them. The noise here is not very relevant. You can see the pictures, how they do the testing of car crashing. He's showing in slow motion. Why do they do this testing? Because they want to make sure that the car is reliable, even against a crash. Nothing happens to the people inside. You can see here. There are two bodies which are made. They are actually sensors. They are provided with sensors. They take the shocks when there is a crash. You can see the airbag also coming in another video, another test. How they do this Ford Mustang, for example. How this seat belt saves the person. When there is a bang from the top, or in other words, the car is toppling, what happens to it? There's a simulated person who is facing this, and this is the airbag. So what happens to the person and how whether he gets injured, all these are studied. You can see this. They take out the person and check. The leg is getting caught, so they have to produce something else there to prevent the leg getting caught or broken. I will show you another video.
Ford today announced an even deeper commitment to American manufacturing, celebrating the production start of the all-new Ford F-150.
So we are not able to see the screen.
Now, once again, I'm coming. Yeah, now you can see. Are you able to see?
It is showing started screen sharing. Still it is. Yeah, now fine.
Celebrating the production start of the all-new Ford F-150.
Are you able to see?
Yes, sir.
Yes,
You're
sir.
able to see now.
Yeah. This is a new car, F-150, which is a very successfully launched car in US. It's an electric car. How they do the testing? This is not an ad, but this is a testing video which has been taken. I would like to show an Indian scenario. This is Lucas TVS, where we do the testing of cars underwater. What happens? Because, in India, it's a very common sight that cars get into the water when there is a heavy rain. So we simulate that the complete testing. You can see there, we had built a tank which is about 100 meters long, and the depth of water is controlled. So the car is made to run underwater. This is a nano car. I thought I would show nano because it is the lowest which was available at the time. So this is the same condition which you have seen in Chennai long back, and also in the Bombay. This is a very common affair. I would like to come back to my presentation. I thought I would show all this to tell you how testing is done by companies, not only abroad, but also in India, how it is being done. These testing, are you able to see my screen?
Yes, sir.
Right. So what happens is, when we do all this testing, we want to make sure that data is collected. How data is collected, I thought I would show you by the videos. Now, there are models which are produced for live data analysis, or in other words, to study the reliability. So this actually we follow Weibull, exponential, or log normal. Don't worry about all these names. These are all statistical names. As engineers, we need to use these things, but not necessarily learn totally on statistics, even though it may help to a large extent. There are softwares available which can do this. So this is an example of a product. Now, the operating time to failure. This is an example which I thought I would show here. To calculate the reliability, operating time to failure 0 to 2.5 days or years, 2.25 to 5 years, 5 to 7.5, like that. So we go on verifying. About 50 products are taken and tested when they fail. And these are all some of the distribution. This, I think you must be knowing, this is a histogram. This is a basic statistics. I don't think you are averse to statistics. So what is important here is, this is a very simple histogram, and we do this first. Now, if you look at this, for example, you have thought that 5 years is a good life for a product to get reliability. Then the reliability is, there are only two items which have failed out of 50. So reliability is calculated as 0.96. So if you look at this is reliability. Or in other words, out of 50 products, only 2 have failed, 48 have survived. Or in other words, if you look at the life of a person as, let's say, 80 years, how many have failed, how many have passed away after 80? That is or they are still surviving. This is the reliability, this is unreliability. So if you take the mean of this becomes mean time to failure. Now, when you look at the reliability graph, we call it RT. Don't worry about all this. This is a safe life. If you look at a product wherein you say 5 years is alive, this is the 10%, B10. B10 is 10% of the components or the product.
Mr. Kumar, sorry to interrupt. You have 10 more minutes.
Yeah, sure.
Thank you.
I know that. So decreasing failure rate, if you look at the failure patterns, decreasing failure rate, constant failure rate, increasing failure rate. Or in other words, this comes from the electronic industry, idealized bathtub curve. This is called a bathtub curve because this looks like a bathtub. If you look at the time scale, this is a time scale, yearly failures. Some of the components or some of the products will fail yearly. This is a decreasing failure rate. Then many components or many products will stand for a long time. Then increasing failure rate, or in other words, human life. For example, initially from 0 to 10 years, there will be decreasing failure rate. 10 to 60 or 70, you get only some diseases, including COVID. Increasing failure rate, people die after about 80 years in an increasing manner. So we follow something called Weibull distribution. Don't worry about this formula. This is just for you to know how complicated it is. So we do this. We take the slope of these graphs. You know, if you would have studied y equals mx plus c, it is something similar to that. So the failure rate, I don't want to spend much time on this because now all this are drawn on a graph paper called Weibull probability paper. This Weibull probability paper is available in Excel, normal Microsoft Excel format. Weibull is part of that. So there is a software called ReliaSoft, who is offering a very good software for doing the complete study of the reliability. Now I thought I would give an example here. That graph shows, this is a Weibull graph. At 10% of life, if you draw a line, the time here is the beaten life. Or in other words, you have tested some 3 or 4 component 4 products and you are able to draw this graph. You are able to predict how many will fail at what time. And at 10% is the life that is generally taken for electronics and also automotive industry. So we take this beaten life. Now, why is the product failing? I told about stresses and failures. Even though the product has been designed to take care of the stresses, which are calculated through finite element analysis, there are additional stresses like temperature, humidity, wave motion, rain, snow, and we also had a small earth tremor yesterday, I think day before yesterday. I think that also adds to some of the product problems. The building may be strong enough, but due to the earth tremor, it may fail. How do we do that? Through a cross-functional management. I would like to go straight away to proactive failure analysis. How do we do it? Analysis of the failure mechanism before the failure occurs, improvement in technology, finite failure mode effects and analysis. I don't know how many of you are conversant with this. If you are not conversant, please note down and see in the Google what it is by evening. FMEA, FTA, fault tree analysis, CAE, simulation, feasibility and model. These are all known to most of you. These are all examples of this. Now, I'd like to go for some 3 case studies to show. If you look at this is a starter motor which we have been designing and making. There is a carbon brush here. I don't know how many of you know this. There is a carbon brush here which runs against the slip ring. This is an electrical product. It is also related to electronics and also mechanical. So we do the degradation matrix. We do the testing of the product at 5,000 hours, 10,000 hours, 15, 20,000 like that. You can load it into the ReliaSoft software. It gives you straight away the Weibull graph. From this, if you draw a line here at 10%, you will know what is the life here. That is the beaten life. Or in other words, in the industry, we don't have to learn statistics to that extent in the engineering industry. So it is enough if you know how to apply this. Now inference, if you look at this brush, we have found out that 50,000 cycles of 5 years, the life is 97.32% with 90% confidence level, which you will know statistics. Beaten life of the brush is 6 years. If you look at 10,000 starts, it is 60,000 starts. Another one, This is a beaten life of another alternator. We have taken 2000. I intentionally showed very old data because I don't want to give the exact data today, because these are all very customer specific and my industry specific. So we do the viable analysis for various warranty claims and the supplies and find out whether the reliability trend has been increasing or is the reliability coming down. If you look at this, reliability has been going up. Or in other words, we have been making 2008 to 2012, we have seen that the reliability of the product has gone up considerably from unreliability of a beaten life of 5,20,622 kilometers to 13,37,970. So it has gone up like that. Now, there are also instances where the customer wants extension of warranty. For example, Maruti is offering 5-year warranty today. They want all back-to-back warranty from suppliers. So we have to analyze what is the warranty expense that we will make by predicting what could be the returns, warranty returns. If I extend the warranty from 1 year to 3 years or to 5 years, we do the analysis, we find this is a tractor industry. One example, 1,500 hours, 1 year warranty was being offered. Customer wanted 2 years, 2,000 hours. So when we do this, we found 17 to 18% increase in number of failure cases, and there is an additional cost of warranty. If you can provide for it in your cost, it is fine. Otherwise, absorb it if you want to really get the business. So without data, you are just another person with an opinion. This is what Edwards Deming told. Or in other words, when people talk about reliability, oh, this product is reliable, that product is reliable, you can't say unless you have data and prove it. It is something like we tell people, this person is very reliable, but sometimes he will fail. So then only you will know why you considered him as reliable and he become unreliable. Or in other words, life, sometimes we think that we are going to live reliably up to the age of 90 or 95, but some people die at the age of 60, 65 because you have no data. Or in other words, healthcare industry will be working on reliability of human beings. So with this, I would like to close my session. So without data, you are just another person with an opinion. I would like to thank PALS and also KCG College for giving me an opportunity to share my complete concept on what we are doing as reliability in the industry. Thank you very much.
Thank you, sir.
I hope I'm on time.
Yes, sir. Shall we go for the flash quiz or after the students' presentation? So,
I think, Robin, you can finish the flash quiz. No? There'll be a break.
okay. Thank you. Ma'am?
Yeah, I'm there, Robin.
Okay.
So for all the participants who have joined us today for the first time, or I repeat it for the participants who are joining us again. This flash quiz is something that we have introduced newly this year. And why would we do that? It is just a quick cross verification, a quick verification of whether the concepts have been understood well. Mr. Krishna Kumar has patiently explained to us on the product reliability. So, it's a quick 5 or 6 questions which we are going to post. And there is a fun element to it, right? You see in that Kaun Banega Karodpati or the Tamil version of it, you have the fastest fingers and all that. So, keep your answers ready, be fast in answering. And then when you come back to the Zoom after the end of the quiz, we can see the leaderboard to see how the, the scores are and who has answered first and correctly. So with this, I'm going to paste a link in the chat box. I hope, Robin, you will do that in the YouTube.
Yes.
I have pasted one link in the chat box. I'm going to give you a brief 1 or 2 minutes. So all you will be required to Gokul S has raised his hand. I do not know for what. You will be required to, register with an email ID and your name. And I would like to repeat, registration, attendance, participating in this flash quiz, and finally giving your feedback is mandatory for you to get an attendance certificate for the session. So if any of you are looking out for an attendance certificate and participating in this session, kindly make sure that you participate.
Ma'am, we are not able to view your screen.
I have not shared it yet.
Okay.
Yeah. So I hope you're able to view it, Robin, now.
Yes, ma'am.
Yeah. So I'm going to get started on the session, the quiz. I'm waiting for all of you to join. So far, 31. I saw close to 183 or 182 members. So at least 70–80% of you should be joining. So how does it work? As soon as I start the quiz, you will get the question. You will be given 20 seconds. So be, quick on watching your browser screen. Don't come into the Zoom screen right now. Be on the browser. I'm at least waiting for it to reach 100. I think the student presenting student teams can also participate. It's currently 90 participants. Okay, it stands at 90. I'm going to start the quiz. The very first question, I hope all of you are able to see your question, and there are 20 seconds to it. Do the suppliers of products and services accept warranty or returns readily? It was touched upon in the session. So give your options or choose your option. It's a mixed opinion. We don't seem to have a unanimous opinion on this. And the right answer is without asking questions. So that is the option that we were looking for. So I hope you've got the hang of the quiz. I'm moving on to the next question. So the second question out of the 5 questions, is quality the same as reliability? Good. I think we have a decision here, and that's supposed to be the right answer too. So yes, but with reference to time, the quality and reliability can be the same, but with reference to time. Moving on to the third. Is reliability considered during new product development? Here again, we seem to have a decision on the answer. And yes is the right answer. The fourth question. MTTF, MTTB, and MTTBTR are the same. Are they the same? This was again touched upon during the session. And the right answer is no. Last and final question. So after this, we will be seeing the leaderboard. So be quick on answering. Product testing is used for reliability studies. Yes or a no? Or there are other two options. Okay, and the right answer is no. So whoever has chosen no, 5% of it only have got it right. So what I would do is I would give you
Madam,
few
the
seconds.
answer is yes, not no.
Oh, the answer is yes.
I don't know where the mix-up has taken place, but the answer is yes. Question mark here. Yeah.
So
product
I
testing
think
is used for reliability studies because that is the way we do that's why I showed several videos on testing. Don't worry where the error has taken place, but the fact is yes.
Oh,
Can
okay.
you change it now in your software?
No, it wouldn't be possible right now,
Okay,
sir.
right.
Okay. Okay. So I think, we'll have to quickly see what is the results. I would give a few seconds for you to come back to your Zoom screen and see the leaderboard. Dr. Chidambara Kumaran. Sir, I think you might have got 5 on 5. Most of you would have got, whoever is 4 on 5 would have got the 5 on 5. So Chidambara Kumaran from Kamaraj College, I suppose. Robin, is that right?
Yes.
Yeah. So Ahmad Sharif, Sri Venkateshwaran, Alex, John, and Rahul. So you seem to have the fastest finger. Probably all of you got this question right. So the score must be 5 on 5. If the 5 of you are here and you want to take a quick picture of this leaderboard screen, I would leave it here for you for a few seconds. So thank you for participating for the rest of you, and congratulations for whoever else has participated.
Thank you, madam. Thank you.
Thanks a lot.
Thank you, Krishna.
Sweta, now you can call the teams.
Yes, sir. I am now delighted to share that the teams of students from KCG College of Technology, MAM College of Engineering and Technology, and Tyagarajar College of Engineering will be presenting to you for a duration of 12 minutes each. First, we have the team from KCG College of Technology, followed by the other two teams. And now I hand it over to this team from KCG College of Technology.
Good afternoon, sir. I hope my screen is visible.
Yes. Go ahead.
So, shall I start, sir?
Yes, sir. Yes, go ahead.
So, good afternoon to one and all present here. We are the students of KCG College of Technology here with our presentation on Indian product examples for high reliability and parameters of identification. And this presentation is brought to you by myself, M. Omar Sharif, Alex John E., Dhanush Mithil, and Arun Manikvasavan. So, what exactly is reliability? Reliability is the quality of assurance of a product, system, or service that will perform its intended function adequately for a specified period of time or will operate without failure given a defined environment. Reliability is a vital key to a success of a product in local as well as global markets. The best example for bad reliability is the Kingfisher Airlines, which is mainly due to poor decision making, bad debt management, and abysmal customer service, which is quite disappointing. We have identified few Indian products that are good in reliability and also show better performances, and these products are listed below. Over to Alex.
Thank you, Omar, for that. Good afternoon, ladies and gentlemen. So our first product here that we've considered is a Bajaj Dominar 400 engine. And among our very competitive Indian automotive market that we have, which consists of such brands like Hero, Yamaha, Royal Enfield, Honda, BMW even, KTM. So among these, the Dominar 400 actually stands out for just how economical it is and yet being so highly powerful, giving out very efficient speeds and power, and just how of an all-rounder it is as an engine. And the three reasons that I've listed below are the three major reasons for why it is. And let me explain why these three reasons are chosen for it. So force induction, when I say force induction, the most relevant terms that come to mind are either supercharger or turbocharger, but the Dominar 400 doesn't have these things, but it's something similar to what they've improved in the Dominar engine. And that is just the volume of air intake that they've improved. And the better that this volume of air intake that they've made better results in a better air fuel ratio, which results in a more complete combustion of the fuel inside the engine. And this just allows the Dominar to travel much better, to give a much better mileage overall. And comparing Dominar to its competitors like the KTM 390, for example, it only gives 20 to 30 kilometers per liter, but the Dominar gives a more of 25 to 35 kilometers per liter. So moving on to the next two reasons, these actually go hand in hand and help each other be better. So moving on to the next slide, please. So let me explain what compression ratio is. Compression ratio is the ratio of the entire engine's volume to the volume of the piston compressing the fuel inside the cylinder. And the smaller this volume that the piston has compressed the fuel into, the higher the compression ratio. So if we look at the graph on the right, we can see that the higher the compression ratio, the better is the thermal efficiency. And this is an Otto cycle because the Dominar engine is a petrol engine and petrol engines work on Otto cycles. So in this Dominar engine, the thing that they've improved is they've increased the compression ratio from the previous 11:1 ratio to a better 12.3:1 ratio. And just because they wanted to increase this, they couldn't. So this is where the engine design had to come into play. And if we look to the right in the picture, what they made different was they installed two cams, which is the small droplet-looking element in the engine that we see. Previously, there was just one of these controlling the intake and exhaust valves, but this time they made it a dual overhead cam. So there is a more controlled fashion of the intake valve and exhaust valves opening and closing, which results in a lesser fuel loss and thus allowing the engine to extract more power from it. Going to the next slide, please. So Bajaj being an Indian manufacturer, it allows Indian customers to access nearly 2,700 service centers all over India. And again, being an Indian manufacturer, parts are very easy to come by. Unlike Royal Enfield, for example, we need to book our service. And I mean, if we have to replace an engine, for example, we have to wait at least 2 to 3 weeks before they give the bike back to us with a new engine. And speaking of durability, I have friends that have bought Pulsars and their bikes have gone beyond 10 to 15 years, and its engines are just very, very durable. And overall, it's just a very cost-efficient and efficacious product. Thank you. Passing it on to Dhanush.
Thank you, Alex. Dhanush Nithul. The product that I have with me today is the Mahindra Bolero, very well-known name amongst Indian customers, launched almost 2 decades back, but still remains to be one of India's favorite pieces. Before we go into the technical aspects of the car, let's talk about a design element. We today live in a day and age where a lot of car parts are being made out of plastic so that the car could be priced more attractively. But the Bolero even today comes with a hard steel bumper, which not only improves the build quality of the car, but it also makes the Bolero a very tough built SUV. Talking about the engine, just like any other car, the engine is the backbone for its success. The M-Hawk 75, as the name suggests, produces 75 horsepower and 210 Nm of torque. For a vehicle like the Bolero, which is going to be primarily used as a workhorse, torque is all you need, which the Bolero offers you in abundance. Talking about the build quality, let's take for instance the Mahindra Scorpio, the Bolero's sibling, which is actually based on the Bolero, but is more modern, feature loaded, and of course more expensive than the Bolero. But the Scorpio did not perform as well as the Bolero in a lot of markets. There may be a lot of reasons for that, but the reason that we believe played a major role is the build quality of the Scorpio. As you could see in the picture shown, Global NCAP's crash test justifies the statement that Scorpio is one of India's unsafe SUVs, whereas the Bolero, on the other hand, is the only SUV in its class which complies with both pedestrian norms and crash test norms, making it a very safe and reliable product amongst Indian customers. Going on to the next slide. Now, I'm sure all of you know that the Bolero is extremely popular in rural markets. Let's look into why. The first thing is the car's rear-wheel drive system. We have a lot of compact SUVs in the Indian market which offer front-wheel drive system. In fact, Tata Harrier and MG Hector, which cost almost 20 lakhs, offer front-wheel drive system. But for an SUV to justify itself as an SUV, must offer rear-wheel drive system. In fact, the Bolero is the only SUV in its class to offer rear-wheel drive system, making it a very capable off-roader. Talking about the suspension, a lot of modern cars in the market today offer coil spring type of suspension so that the car could get a more comfortable and a comfort ride. In fact, India's highest selling SUV, the Toyota Fortuner, comes with coil spring type of suspension. But the Bolero, being a very old and traditional SUV, still comes with leaf spring type of suspension, making the car more rugged and more capable of the road. Next, talking about the car's mileage. With increasing fuel prices every day, mileage is something that an owner is going to look into nowadays. ARAI claims that the car could offer you about 17 kmpl, which is more than what an hatchback would offer you these days, making the Bolero a very efficient SUV. Finally, talking about the price. Especially in the Indian market, for any product to become a success, no matter what it is, how many features you load it up, you must price it attractively. It must be affordable to the masses. I think this is another strength of the Bolero. Starting from almost 8 lakhs, it is cheaper than a lot of premium hatchbacks in the segment. A lot of you might have this question in mind. The Bolero is actually such a good product. Why doesn't Mahindra give it an update? Why doesn't Mahindra add it more modern touches, make the car more comfortable and plush? There's an old saying in the automotive industry. If it ain't broke, why fix it? That's the formula that Mahindra follows for the Bolero. After being in the market for more than 20 years and having sold 1.3 million units, the Bolero still remains to be one of India's highest selling SUVs, making it a very, very, very reliable product amongst Indian customers. Thank you. Handing the session over to Arun.
Thank you, Dhanush. Hi, people. This is Arun. And now we are going to see about another such product, the TVS XL100, which is one of the most important and reliable product that has been in the Indian market for about... Yes.
Yeah. Team, you have 1 more minute.
Yeah. So it is a reliable product in the Indian market for about 4 decades and remains to be the only one left. Being sold about 12.75 million units, it is one of the best sellers of two-wheelers in India. It is the least priced moped with highest fuel economy to more than about 60 km per liter. It provides affordable mode of transportation to thousands of people, that were especially in the rural and suburban areas in India. XL100 is so light, it has a durable frame and power enough to carry impressive loads of up to 139 kilos. Next slide, please. It doesn't just retain its name for quality, but also for the type of service it offers to the customer. They prioritize the quality and comfort of the customer from studying the field reports and the feedbacks rather than focusing on charts. They initiated the change of the engine's design from 2-stroke to 4-stroke, which emits way less pollution than its former version. This displays their concern for not just the consumer, but also the global health. The reason for TVS success with XL100 is its consistency. They stuck with their original popular look with only just minor alterations. As Krishna Kumar Sir said, while the whole market was moving towards the delight of the customers, TVS ensured that it met their needs. The fundamental of any good brand is consistency and the least amount of tinkering. The Excel has been an old workhorse that had kept the company going during their tough times. It does come in an affordable budget and thus is perfect for the price conscious Indian market.
Team, your time is up.
Yes, ma'am. I will just conclude that. So the conclusion of this presentation is that a product's success relies on its reliability and increasing production and demand growth. From the above products, we have listed the parameters which are necessary for better reliability. And we would like to conclude by saying that reliability is one of the keys to a good relationship, and good customer service is no exception. Thank you for allowing this opportunity. Thank you.
Thank you, team, for your presentation on reliability and showcase of few products that stand out when it comes to reliability engineering. It was quite riveting. I now call upon the team from MAM College of Engineering and Technology to present.
Yes.
May I audible?
Yes.
Yeah, very pleasant afternoon, everyone. Yeah. Reliability is a precondition of trust. We, the team from the MAM College of Engineering and Technology, to deliver our ideas on the topic reliability testing on the automobile product development stage. We would like to start this by thanking our guides, Mr. Diva and Mr. Damodar. And let me explain the internal development and evolution of the concept reliability. In the early 1800s, there was a lot of research which happened because of the fatigue issues in the jet coefficient flight. After a century of research, as a solution, the term reliability was introduced in the middle of 1900s. From the later 1900s, the industries were started adapting to the method of reliability testing there. And it's a product and the reliability is a product attribute. How reliable a product will be performed, its intended function in the customer's hands. Customers want trouble-free experience in the using a product. To prevent and eliminate the potential issues of a product in a customer's hands is the ultimate purpose of the reliability engineering. Over time, it has been evolving into a most and must-have product attribute. All the automakers are making significant improvements in the reliability of the product, which is substantiated by conventional reliability performance. Over to you, Satish.
Due to the product design failure is always an undesirable event for several reasons, putting human life in jeopardy. Section inadequate
Your voice is feeble. Your voice is not clear. Satish Kumar.
Satish, you are not audible clearly.
Can some other continue? The team.
Yes, I will. A disaster due to the product design failure is always an undesirable event for several reasons, putting human lives in jeopardy, causing economic losses, and interfering with the availability of products and services. The failure causes comes from the improper material selection and inadequate design of the parts and its misuse. Product reliability is in the marketplace is highly required due to the recall cost. The new product is hard to match the market requirements of the product, like cost reduction and the shortening development time. Higher performance reliability, from the standpoint of system engineering, companies are asked to establish the design process of satisfying the product requirements in the short development time. While product development time of automobiles continue to shorten from 65 months to 24 months. Reliability requirement increases from 0.9 to 0.99. This decline means that the companies have reliability methodologies tools closely tied to the development process itself.
Yeah.
In 1996, the state of Arizona so Firestone that the tread of its tires were separating in high temperatures Firestone sent several engineers to inspect the tires and concluded that normal passenger tires are being used in heavy conditions on dirt roads and off roads and under heavy load. The revelation led by Bridgestone, the owner of the Firestone brand, right, and the Ford Motor Company to issue the recalls of 14.4 million tires in the United States in August 2000 and more in the international markets. And the recalls of automobiles by the Toyota Motor Corporation occurred in 2009 for approximately 5.2 million vehicles because of the parallel entrapment and the floor mat problem, and for 2.3 million vehicles due to the accelerator pedal problem or this recall. As Toyota widened the recalls to include 1.8 million vehicles in Europe and 75,000 vehicles in China. The total recall numbers of cars in the world were considerably 9 million. The US National Highway Traffic Safety Administration, the NHTSA, right, reached a conclusion that pedal misapplication was found responsible for the most of the incidents happened at that time. Jaikilan, over to you.
Yeah. To perform regular function, mechanical product like automobile compares a number of subtitles or model. It are parts of closely interconnected in the mechanism. Each molecule in the mechanical system can be typically specified a functional block. Its reference is reliability. A failure of component in a module is often described the termination of functional block. It therefore the necessity of mechanical engineer to identify all relevant function and perform criteria related to intent function. Next slide. Yeah, before was system which parallel reliability RBD in failure of main parts in main module on affect performance of the other subsystems. There is a serious RBD event failure of single part can be leads to breakdown of whole system. Here, as an engineer, engine generates power, its transmission, drive, and wheel. Each block represents critical module like transmission. The product reliability can calculate the failure rate and lifetime. Yeah, thank you.
Next. The bathtub curve. The bathtub curve was mapping by the rate of yearly infant mortality failures. The randomness of failures with constant rate of during its useful life. Finally, the rate of wear out failures. The product exists in the designing lifetime. In earlier life of product, the following to the birth curve, the failure rate is high, but rapidly decreasing as defective products are removed. The early source of potential failures, such as storage, handling, installation errors, are dominated. In midlife products, generally once it reaches consumers, the failure rate is low and constant. In the period of products, maybe expect the disasters if a design problem in product exists. Before the production, the design problem should be found by the proper method of oscillating life testing. The product lifetime will be increases. In the late life of the product, the failure rate increases. Next. The mean MTB mean time to failure, MTTF. The MTTF means stands for the mean time to failure. This is the average lifespan of the given device. The mean time to failure is calculated by adding an upon a lifespan of all the device and divided by the counts. Next. The mean time between failure. The mean time between failure is the average lifespan. It can be there some failures have happened. It can be replaced and repaired. Next, continue, friend.
FMEA, the failure mode and effect analysis. It involves reviewing the design of many components, assemblies, and subsystems to identify failure modes and their causes and effects. To determine whether an optimum criterion of reliability assessment is achieved, FMEA is to analyze and modify many components. It uses the risk priority number, the RPN, and a qualitative analysis is mainly used in the light of the FMEA tip. It may be described as an approach used to perform analysis of each potential failure mode in systems under consideration to examine the effects of such failure modes on system. There are really three types of FMEs are there, namely the system level FMEA and design level FMEA and process level FMEA. The system level FMEA is there to when the failure functions as well as the failure mode for a product are analyzed.
Sorry to interrupt,
Okay.
but you have 1 minute more.
Okay. Design level FMEA. Next is the design level FMEA. The purpose of performing design level FMEA is to help identify and stop product failures related to design. Next one is the process level FMEA. It identifies and prevents the failures related to the manufacturing assembly process for a certain product. Okay, then the final one is that there are many softwares based on the various methods for reliability testing. The most commonly used one for life prediction is the Weibull plus test. In that, the practitioner attempts to make predictions about the life of all products in the population by fitting a statistical distribution of life data from a representative sample of units. The parameterized distribution for the data set can then be used to estimate if or less characteristics of the product, such as reliability or failure of the specific time, the mean life and the failure rate. Thank you.
Thank you, team, for your enthralling presentation on the topics historical development, reliability disasters, breakdown of automobiles with multi-modules, bath tube curve, mean time to failure, mean time between failure, types of failure mode, and effective analysis. I now call upon the team from Tyagarajar College of Engineering to present.
Everyone, I think my slides are visible and my audio is audible.
Slides are not yet. Just started screen sharing. Showing. If you have any problem, I will project it.
But it started on my screen.
But still, it is not showing anywhere. Now, are you able to? TC?
Yes, sir. Just a minute. Just a minute.
Please go ahead. I am sharing it. TC team, please go ahead.
I
am sharing it for you.
Yes, sir. Yes, sir.
You have to stop sharing.
Robin, he has to stop sharing now.
My laptop has hanged, sir. Just a minute. Just a minute.
Stop sharing, Robin can share.
Robin, share your screen now.
Now?
Yeah, it is
Is
visible.
my slide visible?
Who's sharing now?
I'm
No, your Robin is only sharing, Kripakar. Go ahead and present.
Okay, ma'am. Okay, ma'am. So coming to the introduction, we are the team from Tyagarajar College of Engineering, and we are now going to present about the softwares on reliability, product reliability engineering. And myself, Kripakar, and my teammates are Abhinav, Pranav, and Karthik. So coming to the introduction, I think most of the definitions on reliability have defined by Krishna Kumar sir and the other teammates. So the other definition is reliability is the probability on deciding how the product will work in its defined environment without failure. The probability can be seen in various forms like probability of success, durability, dependability, etc. Next slide, please. So coming to the reliability engineering deals with the prediction, prevention, and management of high levels of lifetime engineering, uncertainty, and risks of failures. The main objective of reliability engineering is to prevent or to reduce the likelihood and the frequency of failures, to identify and to correct the cause of failures, to determine the ways of coping with failures, and to estimate the likely reliability of new designs. Next slide, please. So coming to the roles of reliability engineer, the main role is to identify and report on the potential failures within a process, and to also to design a new system, applying general knowledge to solve the problem, checking new systems or installations are the roles, certain roles of engineers. What type of analysis is a reliability engineering reliability engineer will carry out? First of all, as Sir and my other teammates explained, FMEA is one of the main type of analysis, and others are reliability hazard analysis and fault tree analysis and accelerated testing analysis and etc. With this, I hand over the session to my colleague Karthik.
Yeah, thank you, Krupakar. Next slide, sir. So, reliability and quality both are important aspects. We will see about the difference between the reliability and the quality. Initially, for a general product, the reliability of the product is more, and as the time goes, the reliability is short down. As the graph depicts the first graph, as the time increases, the reliability decreases. The right side graph shows if a process is said to be quality, particularly a mechanical process, manufacturing process, the component to be in the limit, so that the process is said to be quality. It is one of the upper limit and lower limit are the limits. The targets are to be, we have to achieve the targets. And the reliability is the behavior of the product for long term without the failure. So this is a customer satisfaction without failure of the product. Quality also a customer satisfaction that is fitness to intended use, but the quality is for the short span of time, but the reliability is the long span of time without the failure. So the quality can be concerned with the design stage. Reliability and quality are deals with more tools. Statistical tools like P chart, NP chart, they are used to denote the process is quality or not quality, so that we can predict many more results. The next. This shows the reliability and quality difference. Quality deals with the degree of excellence of the product. Quality is a statistical measure, and as well as it deals with accuracy. And the reliability deals with the probability of the products. So reliability is not concerns with accuracy. So a customer will reorder the product based upon only the reliability. Reliability concerns more on the customers. Next, the presentation is handed over to Abhinavji.
Thank you, Karthik. Next slide, sir. Okay, so we have gone through various journals, and the first journal infers that they use SFRAT, that is Software Failure and Reliability Assessment Tool. Okay, according to this software, supports analysis of failure data produced during testing, including trends, tests for reliability growth, visualization, and cumulative failure, time between the failures, failure intensity as well. And SFRAT is implemented in two languages, that is R language and Python, and can be used in computers running Windows, OS X, or Linux. Okay, this software supports 3 failure count and also 2 trend tests for reliability growth. And this journal has chosen a data set from NASA, which consists of 60 unique failure observed over 168 units of test time, and the input format is given in Excel or spreadsheet. They have mentioned 2 main tests, namely the Laplace trend test and running average trend test. And the Laplace trend test is a statistical test of reliability growth, and the second one is a running average trend test, which indicates the system reliability. When the time between the failure increases, the running arithmetic average increases, indicates increasing in system reliability. And it is presently used on larger software applications acquired on or developed by government and private organizations. Next, sir. And the second journal, that is FREET, that a feasible reliability engineering tool. And the objective of this journal is to present methods and software for the efficient statistical, sensitive, and reliability assessment of engineering problem. And this journal shows the possibility of randomizing computationally intensive problems in manners of Monte Carlo type of simulation, and the random variables are given as an input, and the uncertainties are modeled as random variables by their probability density function, and samples are reordered by simulated annealing approach in order to match the required correlation matrix closely. And the assessment of outputs are consist of histograms of output variables, sensitivity analysis, and limits stat functions. And the Fried model features a combination of analytical model and simulation technique, which has been integrated to form specialized software for assessing the potential degradation of newly designed as well as an existing concerned structures. And the full problematic safety formats are thus employed, serving also for the provision of quantity safety level information. Now we next, sir. We deal about.
You have another 1 minute.
Yes, ma'am. I hand over the session to Pranav.
Thank you, Pranav. So we have chosen the ReliaSoft software, which is the ReliaSoftware provides a powerful range of reliability software solutions to facilitate a comprehensive set of reliability engineering, modeling, and analysis techniques. This is a leading reliability solution provider for product test, design, maintenance, strategy, and optimization, and their product supports a wide range of reliability and maintenance analysis techniques, such as live data analysis, accelerated live testing, system modeling, and RAM analysis, reliability growth, FRACAS, FMEA, and RCM analysis as well, to meet and improve reliability of the products, processes, and optimize maintenance planning. Now let us see the various facilities and their functions of the products. So the various products available in ReliaSoft are the Weibull++, XFMEA, Lambda Predict, BlockSim, RCM++, XFRACAS, and SAP. So next slide, sir. So ReliaSoft Weibull++ is a complete live data analysis tool that performs live data analysis utilizing multiple lifetime distributions, warranty and degradation data analysis, design of experiment, and more, with a clear and intuitive interface geared toward reliability engineering. The software offers optionally accelerated live testing for accelerated test planning and data analysis, as well as reliability growth to analyze data from both development testing and fielded repairable systems in order to monitor reliability improvements over time and predict failures before they occur. Next slide. Next slide, sir. So this, yes, sir. The ReliaSoft XFRACAS is a web-based incident failure reporting analysis and the corrective action system designed for the acquisition, management, and the analysis of product quality and reliability data from multiple sources. The software can be integrated with other ReliaSoft applications, which provides intelligent integration between reliability program activities and tools while simultaneously facilitating effective information sharing and cooperative between engineering teams and of any size. Next slide, sir. So the ReliaSoft FMEA includes the risk analysis, maintenance strategy determination.
Your time is up.
Yes, ma'am. So let me conclude it. So this ReliaSoft is a major software which is used for the reliability growth and the failure analysis in all the products, and as well as the built-up structures as well. So this software is majorly used upon various fields, both in the private and the government sectors, and is a major helpful resource for the reliability growth in the reliability testing sector. Thank you.
Thank you all. Your presentations were marvelous. Now it's time to open the floor for questions. Please feel free to unmute and ask your questions, and you may also put your questions in the chat.
I see a question here already on the chat box. Can I speak?
Yes, sir. Yes, sir.
Yes, yes.
Yeah. He says, why is spares material not made as same as original quality in same product? Once product was repaired totally, the reliability will change. Can you say about reliability of spares? Okay, this is a very interesting question. In the industry, what people generally do is when they want to sell it to the customer directly or to the OEMs. For example, automotive components, we supply to original equipment manufacturer, that is the car manufacturers and all that. We ensure that we are having 100% quality, and we ensure that reliability is measured and maintained. Now, basically because the OEMs will stop buying from you. There is a threat. There is a sword hanging on top of our head. If there is a quality issue, for example, in Hyundai, Then I am called for, I am being the senior vice president. Still, I'll be called the next day at 6 o'clock in the morning to meet the Korean directors and explain why it has happened. Whereas, if it is going to be for spares, the seller of spares is generally from the market or from our own spare selling department, wherein people, when they buy the spare, they expect the same quality, but then what they find is a slightly lower level. But if you look at the way companies like Lucas TVS we work, we do not distinguish or differentiate between spare sales and OEM sales. There are many companies who give second quality product to the spares. That is the reason why it is happening, but that trend is changing totally today. I hope I've answered your question.
Sir, we have 2 or 3 questions.
Yeah,
I will
please.
share it because we have collected from the.
Yeah, please go ahead. This I saw in the chat box.
Yeah, these are all the questions.
Whether any special attention given to the equipment used in medical and aerospace industry during reliability testing? Yes, no doubt about that. If you look at the medical equipment, the accuracy is very important, and reliability, that is maintaining accuracy over a period of time, is very important. GE and Philips and also L&T medical equipment division, they make sure that the quality equipments that are supplied have got the reliability that is expected in the market. If there is any problem, the machine will stop. You can't use the machine. So they make sure of that. Same way in the aerospace industry, it is very, very important. So they do the reliability testing of the engines and also the aircrafts much earlier to launch. And when they launch, they make sure that the product is being made properly. Next question, other than the traditional software as a CAD, SolidWorks for design, in automobile to check for it.
இப்ப EOI நம்மளுக்கு வந்து 20 காலேஜ் எத்தனை காலேஜ்?
Can I go ahead?
Yes, sir. Yes, sir.
Yeah, other than traditional software such as CAD or SolidWorks for design, is there other software in automobile to check for aerodynamics, amount of torque being distributed in all wheel drive car during high-speed cornering? Yes, there are several softwares available. For example, in the automobile industry for aerodynamics, we have got CFD analysis. Computerized fluid dynamics analysis. There are few softwares available like Flow and other things. An amount of torque distributed in all-wheel drive car. There are several torque sensors and torque measurement that we do and transmit. The sensors are fitted on the vehicle wheels with a slip ring, and the measurement is taken inside the car. This is very common. What is the biggest challenge in the field at the moment? The biggest challenge today.
Sorry to interrupt, but I think we're having some time constraints. So let's wrap up the question and answer session.
That he will finish it, that questions.
I will finish the third question. It's a very simple question.
Okay, sir.
What is the biggest challenge in the field at the moment? The biggest challenge in the field is to meet the competition from MNCs, particularly, to meet for Indian companies, purely Indian companies like Mahindra, TVS Group, like that, TVS Motor. If you look at this, today the biggest challenge, for example, in electric two-wheeler, Ola has come out with some design from abroad. Then Hero has developed their own. TVS Motor has developed their own. There are several people who are making two-wheelers made with electric drive. So there is the biggest challenge in the field is to ensure quality and reliability. I hope I have answered all your questions. If you still have any questions, you can pass on to.
Yeah, it is only one question is in the chat box. How can we ensure the reliability in design stage, sir?
Through QFD, quality function deployment. See, what we do is what is the quality or reliability in the design stage. We should ensure that the product will meet the customer's requirements, not only specified but unspecified requirements. I used to give example of ordering a masala dosa in Saravana Bhavan or Sangeeta. When you order, you don't tell them how much of oil to be used, how much of crispness you want, but they give, and the chutney they give, is it going to be spicy? Nothing you tell, but he is meeting your requirements and there's a continued repeat purchase. That is the quality at the design stage. They have done a quality function deployment. You can refer to QFD, quality function deployment, by Geo Akai in the Google, and try to understand. There are several people who are using this. Lucas Stevens has done excellent work in QFD. That is one way by which you can try.
One more final question. What is your stand on right to repair by the customer?
Right to repair by the customer has got the right to repair, but then if it is within the warranty period, the manufacturers will not agree. Manufacturers will not accept. Even if we change the horn, if we change the light bulb, they don't agree to it nowadays because they ensure that the whole design is optimum. If you try to, affect the balance of the whole vehicle in terms of electrical, mechanical, and aerodynamics, there will be a problem. So they don't allow mostly.
Okay. Thank you, sir. Thank you for your answers. Sweta, you can go ahead.
Thank you, sir.
Thank you.
Thank you all for your valuable time. I'm sure you had a great time today with the session. I would also like to thank Robin, sir, my beloved teachers, and the college management for giving me this opportunity to do the comparing. I now hand it over to Mr. Arun Dev to deliver the vote of thanks. Over to you, sir.
Yeah, thank you, Shweta. So good evening, everyone. That was an interesting session, a full 2 hours on reliability. Firstly, Ram, for setting the context of this whole Industry Speaks as a champion in PALS for the Industry Speaks events. He has been very energetic in trying to organize different speakers on a range of topics. And I would like to thank you for setting this up. Dr. Annie Jacob, for your opening comments with regard to the importance of this subject in the whole scheme of things, particularly in today's climate. Also, what is very interesting to note was your observation about how reliability is also important in education. So reliability is not only about products and services, it's also about subjects such as education, where you can find a lot of impact as well. Of course, we had Krishna Kumar, as we have heard in some of our earlier talks. Attitude and passion beats knowledge anytime. And what Krishna Kumar brought to the table today is over 40 years of experience in hardcore engineering, both in design, reliability, quality, and a whole range of other subjects as well. The importance of listening to a person like him is that he gives you the history behind it and where it evolved from. And that sort of gives you the whole experience that goes into developing this whole subject of reliability, starting with Lloyd's of London, carrying out insurance for ships, going on to other subjects, and finally, how it was adopted by the automobile industry to meet international competition, to meet customer satisfaction, and not only satisfaction, but also customer delight. He did bring in a lot of knowledge with regard to what is reliability, why is it important, and what is the impact of reliability right from the stages of design. If you attend to a reliability problem right at the stage of design, the savings or the impact on costs will be very minimal, as against trying to do it much later in the development stage or the execution stage. I would also like to thank the 3 teams from KCG, MAMSET, and PC for your deep analysis of different subjects of topics that were given to you. These are not topics that you would normally read in college, but that is the very emphasis about this PALS program of Industry Speaks, we want to push students to look at different areas beyond what they listen in college, what they go through in college, do a little bit of research, and be able to put together a comprehensive presentation on the subject. And of course, finally, we did have some very interesting questions that came up. We'd like to thank SKK, Mr. Krishna Kumar, for being able to address those concerns as well. Also like to thank Shweta for the MC of the session, for managing the time very well and ensuring that everything goes as planned. With that, we come to the end of the session. I thank you very much for your patience to sit through this whole program. I hope there was a lot of learning that will be carried forward and would be useful in your further research and growth in this area. Thank you very much, everyone.
Thank you. Thank you. Thank you, Mr. Kumar.
Yeah, thanks a lot.
I request the participants to submit their feedback and the online quiz. I have posted in the chat box as well as YouTube also.
Krishna Kumar sir, thank you for a great session.
Thank you, sir, for a great session.